Dear students, greetings for the day. In the previous class, we discussed the introduction to dynamics and the vertical projection of the body and the horizontal projection of the body also. In this class, we discuss in detail about oblique projection. Before going to that, we will revise the previous topic. So a body is projected into air in three ways. First one is vertical projection of the body. Second one, horizontal projection of the body. Third one, oblique projection of the body. So when a body is projected in the horizontal direction parallel to earth or parallel to x-axis, then theta is equal to 0 degrees in that case. When the body is projected in vertical direction, then theta is equal to 90 degrees. In oblique projection case, the body is projected other than 90 degrees, that is 0 degrees is less than, theta is less than 90 degrees. So when the body is projected into air with other than 90 degrees, then it is called oblique projection. When a body is projected into air parallel to the earth is called horizontal projection. In horizontal projection, when a body is projected horizontally with initial velocity u, then the body, as it moves in the forward direction with constant velocity u, and as it moves in the forward direction, it gradually falls down and moving towards the earth, since the gravitational pull of the earth is acting downwards the earth. So its horizontal component of velocity u is not changing, but its vertical component of velocity, that is vertical velocity acting in the downward direction, is gradually increases from 0. So when a body at height h when a body is projected horizontally with initial velocity u in the horizontal direction, then it travels with the velocity u at any point. Its velocity is u until touching the ground, and let it reaches to the ground in time t seconds, and let it touches to the ground at point C on the ground. Now this horizontal distance travelled is known as horizontal range. It is equal to the horizontal velocity into time. So here in this case, vertical distance travelled is horizontal distance, and vertical distance travelled by the projectile. time of flight t is equal to so this is called horizontal range. Therefore here 1 is becomes u into root 2h by g also, as t is equal to root 2h by g. So these are the expressions whenever we require these. This is called time of flight t equal to 2h by g under square root, and horizontal range is equal to u into t or u into root 2h by g under square root. Now by considering the second equation, this one, we show that the equation of path of the projectile is parabola, that is the joining the lines, the positions, we obtain this path, parabolic path b to c, which is passing through the origin. The equation of this projectile is y equal to kx square. This is the path of the projectile passing through the origin. Therefore, to show that path of the projectile is parabola, here h or s equal to, from this equation, s equal to y equal to, or from this y equal to half into gt square, or half into g into t. T is equal to x by u. Therefore this can be written as g by 2u square into x square, which is k into x square. Here the constant k value is equal to g by 2u square. Therefore the above equation y in the form of y equal to kx square, where k equal to g by 2u square. Therefore the path of the projectile is parabola. So this path of the projectile is in the form of parabolic equation passing from the origin y equal to kx square, where k equal to g by 2u square. So these are the formulas for horizontal range. Or horizontal range, it is also called horizontal range. Another expression for time of flight. From the vertical distance traveled, we derive this. Second one, time of flight of horizontal. Now In this case here theta is equal to 0 as the body is projected parallel to the horizontal direction. Angle of projection is theta equal to 0 degrees in this case. Now when we consider oblique projection, theta is other than 90. That is theta is less than, and 0 degrees is less than, theta is less than 90 degrees. When the body is projected obliquely with an angle theta to the horizontal, then it also moves in the parabolic path, whose equation is given by y equal to ax minus bx square. Now show that the path of the projectile which is projected in oblique direction is as y equal to k ax minus bx square. So when the body starts from O with initial velocity u, then this initial velocity direction makes an angle theta with the horizontal. Now this initial velocity u can be resolved into two perpendicular components. One is along the x direction u cos theta, and one is along the y direction u sin theta. So this horizontal component u cos theta remains same throughout its journey. Until it reaches to the earth. So in this case, here vertical component is u sin theta is affected by the g, because it is in the direction of gravitational pull of the earth. So earth's gravitational force acts vertically downwards towards the earth, but here vertical component is acting vertically upwards u sin theta. Hence as the body moves up, its velocity, vertical component of velocity u sin theta gradually decreases and finally becomes at point A, where its vertical component of velocity becomes 0, is known as maximum height reached by that projectile. So when we draw the projection, this is AB represents the maximum height. So, and the horizontal component u cos theta, throughout its journey at any point in its path, it remains same u cos theta. So due to the u cos theta, it moves in the forward direction with constant velocity u cos theta, and finally it touches the ground at point C. So the horizontal distance travelled is known as range or horizontal distance. Is equal to horizontal velocity into theta. So this is the first expression, horizontal distance travelled, or from this, let this be x, let this be x. So t is equal to x by u cos theta. And from this figure we calculate the vertical distance travelled AB. Next, vertical distance travelled is equal to this is ABH maximum. This is obtained at any instant of time. Let it be y at any instant of time, as it is by drawing the projection to y-axis. We obtain, let in t times let it reaches to the point D. Then here by drawing vertical, it cuts any point on the x-axis, that is E. Then this is the horizontal distance travelled. Now when we draw the here perpendicular to y-axis, then this is the vertical distance travelled, let it be y. At instant of time t. From s equal to ut minus half gt square as the body is moving up. Here u means vertical component of velocity u sin theta into t minus half gt square. But t is equal to x by u cos theta. Therefore, this may be written. So the parabolic equation of this path of the projectile is in the form of y equal to ax minus bx square, parabolic equation. We show that y equal to vertical distance travelled at any instant of time t. So u gets cancelled, sin theta by cos theta is equal to tan theta. X minus 1 by g by 2u square cos square theta into x square. The above equation is in the form of where a is equal to sin theta by cos theta, that is tan theta, and b equal to g by 2u square cos square theta. It is constant. A and b are constants. A value is equal to sin theta by cos theta. So therefore the path of the projectile is parabola. So we can write that path of the projectile is a parabola. Now let us derive expression for this maximum height. So before going to that, I will explain once again. Consider a body at point O which is projected obliquely with initial velocity u, whose direction is making an angle theta with the horizontal. This this velocity u can be resolved into two perpendicular components: horizontal component u cos theta along x direction and u sin theta along y direction. This u cos theta does not affected by the value of g, as the body is moving in the forward direction, due to which body moves in the forward direction. Throughout its journey, moving with the constant forwarding velocity u cos theta, horizontal velocity only. As the body moving up, because gravitational pull is acting in the downward direction, u sin theta is affected by g, and as it moves up, it gradually decreases. So at any instant of time t seconds, we calculate the horizontal distance travelled by the body and vertical distance travelled by the body, and show that at any instant of time the vertical distance travelled by the body is in the form of parabolic equation y equal to ax minus bx square, which is not passing through the origin. So let us show that. What is here? Horizontal distance travelled is also known as horizontal range. Let it be x. OC is equal to x equal to u cos theta into t. In t seconds, suppose it reaches to the c, then u cos theta into t, or t equal to x by u cos theta. Let us use the value of t in the second expression for vertical distance. So vertical distance travelled is obtained by using the equation s equal to ut minus half gt square, or u means here u sin theta in vertical direction as the body is moving up. So for vertical distance we use vertical component of initial velocity u sin theta. So u sin theta into t, t value is x by u cos theta. Here we substitute instead of t, x by u cos theta minus of g into t square. Instead of t square, here we substitute x by u cos theta whole square. So by simplifying it, we write y equal to here sin theta by cos theta, u gets cancelled, into x minus g by 2u square cos square theta into x square. So here this equation is in the form of y equal to a x minus bx square, where a and b are constants, and a value is equal to sin theta by cos theta or tan theta, and b value is equal to g by 2u square cos theta. So the above equation represents the parabolic equation. Therefore, we can say that path of the projectile is parabola in the case of oblique projection. Now we derive expression for maximum height reached by the body. So let us derive the expression for maximum height reached by the projectile, that is h maximum. When the body is projected obliquely with the initial velocity u, then its velocity can be resolved into two perpendicular components, horizontal component u cos theta and vertical component u sin theta. As the body moves up, this vertical component of velocity u sin theta is affected by g, and as the body moves up, u sin theta gradually decreases, and on reaching the maximum height, its value becomes 0 at a. Suppose that the body reaches to the maximum height at a. Therefore, from the equation v square minus u square equal to 2as, here final velocity u sin theta value is 0. U means initial velocity u sin theta. It is equal to, as the body moves up, a is equal to minus g. Here a equal to g minus g, u equal to u sin theta, and s equal to h maximum, that has to find out. Let the body takes time to reach the point A. Let it be t. T into s. S means here h maximum. So from this, 2g h maximum is equal to u square sin square theta, or h maximum is equal to u square sin square theta by 2g. Therefore, the maximum height reached by the projectile which is projected in oblique at an angle theta to the horizontal, then maximum height reached by that projectile AB is equal to u square sin square theta by 2g. Now let us derive the expression for time of ascent, that is time taken to reach the maximum height 0 to a. Let this be Ta is equal to, so second expression for time of ascent. So when we project with initial velocity same u, it can be resolved into u cos theta and vertical component of velocity u sin theta. Now here our question is to find the time of ascent, time taken to reach the maximum height, that is time taken to travel from 0 to a. Expression for time of flight. Take the same figure here, u equal to u sin theta, a is equal to minus g, and final velocity v equal to u sin theta equal to 0 at a, at maximum height. Therefore, from the equation v equal to u plus at v is equal to 0 at maximum height, u sin theta becomes 0, and u next u equal to u sin theta, a is equal to minus g, for plus into minus minus g into t is time of ascent ta. From this gta is equal to u sin theta or time of ascent ta is equal to u sin theta by g. This is the expression for time of descent. Now let us derive the expression for time of descent. Time of descent is the time taken by the body to reach the ground from its maximum height, that is the time taken to travel from A to C, that is return journey, nothing but. Therefore, here in this case, here u sin theta becomes 0, initial velocity at A. Vertical component of velocity is 0 here in the downward direction. And C is, this can be derived in two methods. Expression for time of descent. From the equation s equal to ut plus half at square, s is nothing but h maximum, and in this height is h maximum, and u is 0. Of g into t square. Therefore, t square is equal to 2h maximum by g, or t is equal to square root, t means here td square, 2h maximum by and this is equal to nothing but under square root 2 into h maximum is already attained as u square sin square theta by 2g, here 2 by g into, so from this 2 gets cancelled, g into g, 2g square, so td is also equal to u square, since this has root we can write this as whole square. Therefore, td can be written as u sin theta by g. This is equal to ta. So time of descent is equal to the time of ascent. Therefore, let us from the expression is equal to ut plus half at square. Here u, initial velocity at point A is u sin theta is equal to 0 and plus t into half gtd square, time taken to reach the ground from A. Therefore, td square is equal to h maximum by g, or td equal to 2h maximum by g. This can be written as 2 by g into h maximum value by substituting the h maximum value, u square sin square theta by 2g. 2 gets cancelled, and this can be written as u sin theta by g whole square. So square and root gets cancelled, 2 into half. Therefore, u sin theta by g. This is nothing but time for taken for reach the maximum height, time of ascent. Therefore, td is equal to ta. Now, we can derive the expression for time of flight. Capital T, total journey time, that is from 0 to A and A to C. So after traveling, it's travel starting from O, then after passing through A, it reaches to the ground at C. The total journey time taken to reach the point C is called total journey time, capital T, time of flight. This is simply by adding also. This can be obtained in two ways. First method, time of flight is equal to time of ascent plus time of descent. So by adding this u sin theta plus u sin theta by g plus u sin theta by g, that equal to 2u sin theta by g. This is the expression for time of flight. Now we use second, we derive the same from second method. Let the total journey time be t equal to capital T, that is Ta plus Td is equal to capital T. total journey time. Now during this travel, it starts from ground and again reaches to the ground. So vertical distance traveled, vertical displacement is 0. From s equal to ut plus half at square equation. Vertical displacement traveled is 0 after reaching the body to the point C after its projection from O. Again it reaches to the ground C. So its vertical displacement is 0 and u is equal to, here when it starts journey from O, u equal to u sin theta here u equal to u sin theta into total journey time t. A means here acceleration into minus g, therefore half into g into t square. So from this expression half gt square is equal to u sin theta into t. T, when we divide with t on both sides, we get gt is equal to half gt is equal to u sin theta. Therefore, time of flight t is equal to u sin theta by 2u sin theta by g. This is the expression for time of flight in another way. If we don't know the time of ascent and time of descent, and if we know the total journey time t or u and g and theta values, then we use this equation to find the time of flight. If we know the time of ascent value ta and td values, then we simply, to find out the time of flight, we add time of ascent plus time of descent values ta plus td. Or if we know the u value and g value, t value, theta value, then we use this formula to find the time of flight. Last topic, horizontal projection. Already we did this. Horizontal projection or horizontal distance traveled is nothing but horizontal range. So horizontal range is nothing but O to C after starting its journey. This is horizontal range RH. Already this is equal to horizontal component of velocity u cos theta into time of flight. Therefore u cos theta into 2u sin theta by g. Therefore this 2 sin theta cos theta u into u square, 2 sin theta cos theta can be written as 2 sin theta in brackets u square sin 2 theta by g. This is the expression for horizontal range. If we know the values of u and theta, then we can calculate the horizontal range u square sin 2 theta by g. So when a body is projected with initial velocity u, then its horizontal component of velocity u cos theta, due to which the body moves in the forward direction, that is from O to C, and it touches the ground at C. So horizontal distance is equal to O to C, that is equal to RH. Therefore horizontal distance travelled or horizontal range travelled by the body is u cos theta into time of flight t. We derive the expression for time of flight as 2u sin theta by g. Therefore u cos theta into 2u sin theta. In this u into u square, and 2 sin theta into cos theta can be written separately in bracket, whose value is equal to sin 2 theta. Therefore, sin 2 theta into u square by g. Therefore, we find the horizontal range of obliquely projected body. If we know the initial velocity u cos theta and theta value, then we shall find out the horizontal range by using this equation. Now maximum range is obtained when 2 theta is equal to 90 degrees. So when theta equal to 45 degrees, sin 2 into 45, sin 90, because sin 90 for theta equal to 90 degrees, sin has maximum value. Therefore sin 90 is equal to 1. So maximum range is u square by g for sin theta is equal to 45 degrees. So when we project the body at an angle of 45 degrees, then we obtain the maximum range for a given initial velocity. Let us complete the class. If you have any doubt, please contact me.